When we graph 2 tangent x, you need to memorize something. Have this memorized that a tangent curve is increasing and goes to the origin. We look at this number like the amplitude number, and then we calculate the period according to this formula. B is the number in front of x, so the period is going to be not 2 pi, but just pi over 1, which is pi. Normally when we graph, we go over and mark that pi, but in this case, because the tangent graph is centered at the origin, that pi is split half on the left and half on the right. So I don't mark pi like that. I would mark 4 tick marks, 2 on the left and 2 on the right. But that is that's the boundary of my tangent curve. That's where the asymptotes are going to go. Make sure you cut that interval in half and half again. I noticed several of you on the homework weren't doing this. Make sure you're doing this. It's really important. So you're going to have asymptotes like this, and then you're going to have to draw your graph. Now, the way that this works, you don't really have to think too hard as long as you remember that it's increasing. If you know that it's increasing, we can just say, let's just make that number 2 bigger. So I go to my mark, I'm going to do -2, 0, and +2 to make the numbers fit. So there's one period of your tangent function. Now you're going to have to fill up the graph. I want you to draw the rest of it. I'm going to try to do that quickly. Go over 4, go over 4 more, go over 4, go over 4, so I missed. All right, and then I'm just going to go here, 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 here. And then notice we would also have part of a curve there. -2, 0, 2, -2, 0, 2. And then this would be the right half of the graph. I noticed several people on your homework didn't draw the little pieces on the end. Go ahead and draw whatever you would see, including like partial pieces. Now a cosecant. I think it's hard to draw a cosecant, so what we're going to do is draw the sine function. The reciprocal cosecant is sine. So really I'm going to start with this. And again, I can see the amplitude number is 3, and then the period this time for a sine function, 2 pi over b. 2 pi over 1/2 in this case. Don't mess up your fraction. Multiply by the reciprocal. 2 pi times 2 over 1 gives me a period of 4 pi. Period is 4 pi. So we're going to go over here and mark 4 pi. We mark 4 pi. We cut it in half and half again. We're trying to split the interval into 4 equal parts. So those 5 marks split that interval into 4 equal parts. And so we've memorized a couple of things about a sine wave. A sine wave starts at 0. If you look at the unit circle, the first sine number is 0 right here. Okay? And so if you memorize that sine starts at 0, it makes this graph kind of easy to do without having to do a lot of calculations. I know a sine wave is going to start at 0. And then my next sine number is 1. Okay, now I kind of forgot to mention, it should have said 0 times 3. And now we're going to do 1 times 3 is 3. So that's why it goes here. And then the next sine number, 0 times 3. And then the next sine number, -1 times 3. And then the next sine number is back to 0. So we've got that sine curve. Extend it out. Here, here, here. And so I want you to draw it. Some of you have been skipping this step. And I think it's much easier and it's just better when you draw it. And technically that's invisible, it doesn't really exist. So I get it why you might leave it out, but I want to see it. Draw it lightly, draw it dotted. Some of you have been using different colors. That's fine too. But I like seeing that for the next part of the graph. We are drawing a cosecant. We're drawing a cosecant graph. So we've got to do the reciprocal. And essentially what that's going to do is flip all the humps. Now, you're going to have asymptotes, and I believe I told you to put it through the x-intercepts. And that's true, but it gets confusing when you start shifting things. So this isn't shifted, but once you start shifting, what I want you to notice is that the asymptotes will be through the midpoints of the sine of the curve. And what I mean by that is don't go through the high point and don't go through the low point, go through the midpoint of the graph. All right, your asymptotes are always going to go through the middle. So when you start shifting things around, don't really worry about the x-intercept, worry about where's that middle of the graph. And that should make sense to you because the final product is going to be this hump flipped. And if you put your asymptotes in the wrong place, your graph's going to look all messed up. So out of all of that, the answer is red. So technically, all the dotted stuff is invisible. It's not really there. But I still want to see it. Draw it lightly, draw it dotted or something, and make sure you make it obvious that the answer is the right color. A cotangent. I think it's important to memorize two things. It's decreasing and it's not centered at the origin. Tangent is the only one that's different. Tangent is the only one that's half on the left and half on the right. Every other one acts the same way. So we've got this A number, and the period is pi over B, not 2 pi. So that's 1, so pi over 1 is pi. So we do like all of the others. Mark pi, cut it in half, and half again. There is no shifting, so we can just draw our asymptotes through the outside boundaries. And as long as you've memorized that cotangent is decreasing, all you really have to do is make that number 5 fit. All right? I'm going to go 5 and 0 and negative 5 so that it's decreasing. The end. So again, draw the rest of the things. You got a 4, you got 4. So I'm just going to. I want you to do the dots and do a better job. I'm just telling people. Now, the next one. You're going to have a question on the quiz that maybe doesn't want you to graph it. All it'll say is, tell me about this equation. What do you know about it? What's the amplitude? What's the period? What's the shifting do? So make sure you can answer that question. So with this problem, if I said what's the amplitude, that's this number. That's the amplitude, right? And then the period, 2 pi over b. B is this number in the front of the x, 1. So the period here, 2 pi over 1, is 2 pi. Now the shifting. A lot of people get confused by this negative 5 in the front. They want it to be the amplitude or a flip or something like that. That's not an amplitude. That's not a flip. I think you would understand it better if I put it in the back and said minus 5 at the end. It's a little bit more obvious that this means down 5. That's a downshift. And you need to recognize it even when it's in the front. And so I think the question is going to say, what's the vertical shift? And you're going to say down 5. I would be okay if you said negative 5 or minus 5 or whatever, but down 5 I think is the best thing. Then, instead of horizontal shift, it's not going to say horizontal shift, it's going to say phase shift, which I know is kind of confusing, but just know that that means horizontal. Process of elimination, you know what everything else means, that means horizontal. And what I said to do was look here and find the number that makes 0. So if you look at that expression, positive pi over 2 makes 0, and so that's how we know the phase shift is going to be right pi over 2. So there is going to be a question that says, just tell me that. Don't worry about the graph, just be able to tell me that. But since this is a review, I'm going to go ahead and draw it. Okay? So what I would recommend you do is kind of ignore the shifting for a bit. And let's just look at the basic sine function without any shifting. That's what I'll do to start. So we've memorized that the sine function starts at 0. and that comes from the unit circle, but the first sine number is 0, so make sure you remember that. The period is 2 pi, so we go, okay, 2 pi, cut it in half and half again. Those are going to be my marks, but we start at 0. So I look at this amplitude number of 4, and my first number is going to be up here. I'm going to make an X there, and then down, and then -4, and then here. That's going to be what one period of that non-shifted sine curve looks like. So you can draw that lightly or draw that dotted if you want, or you can just draw the X's, it'd probably be okay. But I don't really care for you to fill up the screen or fill up the sheet with that, because that's not the final answer. I want the final answer, the full version. So what we need to do is take all of those points and shift them down 5 and right pi over 2. Now notice pi over 2 is 2 tick marks. So when I say right pi over 2, I mean right 2 tick marks. Each of those points, looks like I'm going off the page a little bit. Each of those points needs to go down 5 and right 2. So that X becomes this point. This point, down 5, and right 2 is this point. Down 5 and right 2. This one's off the page, down 5 and right 2. And then down 5 and right 2. So there would be one period of my shifted sine curve. Go ahead and finish the pattern. And here, and here, here. And understand that if you messed up, it's going to be obvious. If one of your dots is in the wrong place, your graph is going to look distorted. So if your graph looks distorted, you probably messed something up. Go back and double check. Secant. Kind of the same thing as the last one, but instead of secant, you're going to think about this as a cosine. So 6 cosine x is what I'm looking at. And you can see this is your A number. And we can calculate the period. Period is going to be 2 pi over 1. And we can see the shifting, but we can do the shifting later. But anyway, I see it's going to be left, pi over 2, and down 3. So let's just focus on 6 cosine x. 6 cosine x. I would mark off a period. Notice I don't give you any tick marks here. So how I usually like to do this, every 4 marks is pi. 1, 2, 3, 4. That's 2 pi. 1, 2, 3, 4. That's 3 pi. That's not the only way to do it. You can do it however you want, as long as you're consistent. But I mark off that period of 2 pi. Cut it in half, and cut it in half again. And then you want to remember where cosine starts. What's your first cosine number? 1. Memorize that. First cosine number is 1. So you look at 1 times 6, it's going to be 6. My first cosine number is going to be here. And then you've got 0, 1. Your next cosine number is 0 times 6. And your next cosine number is -1 times 6. And your next cosine number is 0 times 6. And then you're back up at 6 again. So it's a little bit weird. I know that doesn't look like a cosine wave. It looks like a V shape, but that is a cosine wave. Make sure it's rounded, not pointy. So what? What I would do, I wouldn't draw this. I would shift it. So we're supposed to shift left pi over 2 and down 3. Left pi over 2 and down 3. Remember, pi over 2 is 2 tick marks. So left 2 tick marks and down 3. Left 2 down 3. Left 2 down 3. Left 2 down 3. Left 2 down 3. That's your first period of, I'll draw that dotted. That's the first period of the cosine wave. So just continue the pattern. That's going to be here, and here. It's tempting to not draw that because technically it's not there. That's not our answer. That's not the secant graph that we're after. That's cosine. It's a shifted cosine. Remember where I said to put the vertical asymptotes. You're thinking, the other day I told you to put them on the x-intercepts, but that's not going to be good enough. That's not going to be good because that's not going to be centered. We want those asymptotes to be at the median points, not the x-intercepts. So we want those asymptotes to be through the middle part of your cosine wave. So that's what we do. Okay. And then since it's a secant, we do the reciprocal. We're going to flip the house. So you're going to U shape here, U shape here, here, here. Secant. Out of all that, the answer is blue. Everything else is really invisible. We've already done a tangent, but here's another one. You've got memorized that tangent is increasing and goes through the origin. It's the only one that does it like that. It's the only one that's half on the left and half on the right. So you can see the A number, and then the period, pi over b. That's going to be pi over 1/2. Quit messing up your fractions. Multiply by the reciprocal, that's going to be 2 pi. Period here is 2 pi. So if that's 2 pi, then you put half of it on the right side and half of it on the left side. That's going to be a period of 2 pi. Cut it in half and half again. It's really important that you make those marks. If you don't make those marks, I think you're going to put your dots in the wrong place. I've got asymptotes there. Let's try it here. And then really all you have to do is say, well, this number's 3, and it's increasing. So I just put my numbers down so that it does those things. -3, 0, +3. There's one period of the tangent curve. Let's go ahead and draw. Set it. -3, 0, and 5. All right. Now, here's some problems you might have totally forgotten about. These were problems from earlier in the chapter, 6.1 and 6.2. They're very, very important, and I put them on the quiz. So let's look at them again. If you know what you're doing, it's like a 5-second question. It's really quick if you know what you're doing. If you had this unit circle, it would be really fast, and you don't even have to think at all. I'm probably not giving you the circle, but I probably will give you the chart. If you're looking at the chart, you're going to say sine 4 pi over 3, and it should be no problem at all to get to this number right there. But it might be negative. That's the hard part. You have to think about where this angle is to know if this answer is positive or negative. So, you think it's negative? Yeah. Here's what we do over and over again. You memorize that this was pi and it's 2 pi. When I've got a denominator 3, I'm going to get a denominator 3. So I'd make this 3 pi over 3, and this would be 6 pi over 3. Notice that's still pi, and it's 2 pi. So I want to say, well, where's 4 pi over 3? And remember, we're talking about a unit circle, but as we go around that unit circle, 4 is just past 3, or 4 pi over 3 is just past 3 pi over 3. We are definitely in the third quadrant. And what do we know about sine numbers in the third quadrant? Negative. So, what did I just find? What is that answer? It's important that you know that if you're going to understand this question. That's the y coordinate. It's really hard to understand without looking back at the unit circle. So what this question really says is, give me the y coordinate at this angle. Good question? Okay, what?
Can you go back up before?
Let me finish my thought here, and then I will. So if you're asking, what's the y coordinate at this angle, you go to that angle and see that the y coordinate is negative square root of 3 over 2, right? So we're really just finding the y coordinate. All right. What you need, man?
So would I be wrong in doing it by looking at the pi over 3 and having the 4 left over and multiplying 4 and 60 degrees to get 20 or 220?
Well, okay. You can convert it to degrees. You can, all right? But it's kind of a waste of energy to do it that way. But yes, you absolutely could do that. But you know, sometimes you're not going to be allowed to have a calculator. So you're doing that kind of stuff, and sometimes it's going to be hard without a calculator. I just think it's probably easier and faster to just completely bypass degrees. But yeah, you could do that. All right, next problem. Let me just put this out. Cosine 5 pi over 6. So again, you look at this chart. You look at this chart, and you got a cosine, and you got a pi over 6, and you're looking right here. So I know it's square root of 3 over 2, but it might be negative, depending on where we are. So we always go back to this picture. I've got pi and I've got 2 pi. Since I have a denominator 6, I make this a denominator 6. That's 6 pi over 6 and 12 pi over 6 to make pi into 2 pi. So if I'm looking at this circle, 5 is right before 6. I'm in the second quadrant. What do I know about cosine numbers in the second quadrant? When I say cosine numbers are negative, what do I really mean? The x numbers are negative. Tangent, 5 pi over 4. So you're looking at tangent, you're looking at pi over 4, we're looking at this 1. Unless it's negative. So we go, same thing, pi and 2 pi. Denominator 4, so 4 pi over 4, and 8 pi over 4. 5 is right past 4. We are in the third quadrant, and you should know about tangent in the third quadrant. All students take calculus. If you learn that saying, the T for take also stands for tangent. That's telling you that tangent is positive in that third quadrant. That's not very mathematical. If you want to think about it this way, think about an XY point. In the third quadrant, X would be negative and Y would be negative. We know tangent is the ratio Y over X, so a negative over a negative is positive. That's the way I always used to think about it. Next one, sine 3 pi over 2. So you look at sine, you look at pi over 2, you should be able to get 1 really quickly. Unless it's negative. So this one's actually easier than some of the others, but people miss it more often. We talk about pi into 2 pi a lot, but you should also have memorized up here is pi over 2, and down here is 3 pi over 2. So this problem is literally on the x-axis, or not the x-axis, the y-axis. It's this angle that points us to right there, like 270 degrees if you want to go back to degrees, but we don't want to. It's just downstairs. And what do I know about sine numbers or y numbers down there? They're negative, so that's negative 1. Literally, what I'm finding, if you go back and think about the unit circle, I'm finding the y coordinate of that point. Remember, the unit circle has radius 1, right? I'm finding the y coordinate of that point. Okay, last one, cosecant. Cosecant isn't in the chart. If you go back and look at your notes, I gave you a bigger chart with 6 rows. You're not going to have that. In fact, I don't even really like the bottom row either. You really only need the top 2 rows, and you can figure everything else out after that. Cosecant is the reciprocal of sine. So what you want to do is look at sine 2 pi over 3. So we've got sine, we've got pi over 3, we're looking at this number right here, square root of 3. Unless it's negative. And so we look at where 2 pi over 3 is. Now maybe you're getting good at this and you can visualize without drawing it out now. Denominator 3. So I'll make this 3 pi over 3, and this will be 6 pi over 3. So I'm looking at 2 pi over 3. It's going to be right before 3 pi. I'm in the second quadrant, and what do I know about sine in the second quadrant? Or y. It's positive. Now, that's not my answer because I haven't answered cosecant yet. Cosecant is the reciprocal of sine, so I'm going to do the reciprocal. I just flipped that result, and I got 2 over square root of 3. All that's left is you would need to rationalize the denominator. That's going to give you 2 square root of 3 over square root of 9, which is 3. It's really hard to visualize what that means, because that's not the y-coordinate, that's the reciprocal of the y-coordinate at that point. Last slide. These problems are also really important. Sine theta equals -1/2. Most people don't understand what I'm asking here, but think about what I'm asking. I'm asking you, what is the angle where the y-coordinate is -1/2? Find me an angle where the y-coordinate is -1/2. So if you look at your circle, and we want to find a y-coordinate that's -1/2, you're looking here and here. So you can look at the circle and see the answers immediately. I'm looking for the angles, plural, that produce a y-coordinate of -1/2. Probably not going to give you the circle. Chart though. And it's very similar to what we've been doing. So if you look at the chart, you can see a sine and you can see a 1/2, and that's going to lead you to pi over 6. That's not the answer though. Okay? It's not pi over 6. Pi over 6 is a reference angle. And we want the pi over 6 where sine is negative. So I might just say a pi over 6 negative. Notice this extra step right here means I want an answer between 0 and 6.28. So you can't have a negative. Don't tell me negative pi over 6 for your answer here. Your answer will not be negative. It has to be between 0 and 2 pi. Anyway, that's a reference where sine is negative. So you constantly have to go back and think about, well, where is sine going to be negative? And so we're constantly going back to this picture. We know sine numbers are going to be negative downstairs, or y numbers are going to be negative downstairs in the third and the fourth quadrants. So we've got a pi over 6 reference angle. What that means is this angle. And this angle right here is also pi over 6. Okay, so what? We've got a denominator 6, so get a denominator 6. This is 6 pi over 6, and this is 12 pi over 6. So what we're looking at for this first angle right here, notice it's just past the 6 pi over 6. It must be 7 pi over 6. And for the other one, notice it's right before 12. It must be 11. 11 pi over 6. So about what we just found. Give me the angles that produce a y-coordinate of -1/2. Now, secant. I don't know how to do secant. If you go back and look at your notes at the bigger chart, you can do secant. But without the bigger chart, you're stuck with this. So it's fine. I'm going to just take my ball and go home. I don't like playing with secant. I'm going to do the reciprocal of both sides. If you do the reciprocal of both sides, it's easy because we can just look at the cosine row of the chart. Cosine theta equals -1/2. There, there, I'm looking at that. The answer is not pi over 3, it's pi over 3 reference where cosine is negative. So we go back and look at that same picture. And we think about where cosine is negative. Cosine, or x numbers, are negative in the second and third quadrants. So we've got a pi over 3 in the second and a pi over 3 and the third. So get a common denominator and call this 3 pi over 3, and you can call this 6 pi over 3, but we don't really need it. This is just before 3, so it must be 2. This is just after the 3, so it must be 4. The answers are 2 pi over 3, 2 pi over 3, and 4 pi over